Okay, so today I'm covering function and composition, which tends to be difficult for a lot of people, which is probably why there's so many of you on this on this live, because it does tend to be confusing. So hopefully this will clarify it for you. So just as a recap of what is a function, because you kind of need to know what a function is to know function composition. A function is a specific type of relationship between two variables where if you have an input, there's only one possible output that you have with it. So you can't plug in a number and get two answers out. You'll only get one answer out when you plug in a number. And if an equation is a function, instead of writing y equals, we'll use f of x. So the x parenthesis, and it's just the same thing. Y is the same as f of x. We just use this special notation so that you know specifically that it is a function, and it actually allows you to see what you're plugging in. And it's actually really nice. Function notation is really nice when we're doing function composition. So hopefully that will kind of clarify things for you. Just as a side note, f parenthesis x parenthesis f of x is not multiplication there. So because we're usually only working with two variables, x and y. So if you see another variable like f written like this, then it's not multiplication, it's just function notation. And when we do stuff with function notation, we're only interacting with the right side for the most part, and that will be true with what we're doing with function composition, is we're mostly just interacting with the right side. The only thing we do on the left is plug in something, but we never like manipulate the left side other than just replacing stuff. We don't divide on the left, we don't do anything like that. We are just evaluating and doing stuff on the right. So function composition, it's written, if you have two functions, f and g, you have a circle in between them. It's an open circle. So that's read out loud as f composed g. Or I will write it in the function written form, f of g of x. And then if it's in the other direction, it's g of f of x. So this is a new notation where you have an open circle. It's not the letter O. So it's a different. It's like the dot. It's just that it's open. And that means you're doing a function composition. So you could see it written multiple ways, but what it basically means is that you are taking one function and putting it into another. So this chart comes from the textbook. You have your input x, and you plug that into your function g, and you get some output, some answer out. Then you take that, and that is now your input to the second function. So it's like you're going through multiple functions. You're embedding a function into another. So that's essentially what you're doing. You're taking the output of one and plugging it into the other, and then getting a new output. So that's what function composition is. And out of the notation, you're going to see the notation on the left with the circle, but I always write it as the notation on the right, where it's a function inside a function, because that helps see what you're doing. So we've got two functions here. F of x equals x cubed minus 4x, and g of x equals the square root of 2x. And we're told to find the following. F of g of 2, so that's the one on the left, that's how you read that out loud. And then on the right, we have g of f of 3. So when you're simplifying these things, you are basically following the order of operations. Everything goes back to the order of operations, and we work inside out. So when you see f of g of 2, you need to first do the inside, which is g of 2. So you need to figure out what is g of 2. And so we take our function. Oh, what was the last bit of the diagram on the last slide? Yeah, f of g of x. I can, if I find my mouse, zoom in there. Yeah, so we're taking one function, putting it inside the other. So we've got f of g of 2. So I need to first do g of 2. And that will take me to g of x. So I've got, oh, I don't know why that disappeared. Oh, last time this happened, I had to close my slideshow and then start it up again. Let me try that. So I've had this happen to me before, where it just, for whatever reason, just makes things disappear. There we go. So let's actually, we start with g of x. So g of x is the square root of 2x. And we are finding g of 2. So it's normally g of x, but now we're replacing x with 2. So everywhere that you see x, you're going to replace that with 2. So g of 2 is the square root of 2 times 2. And with functions we evaluate, we only do the right side. We don't do the left. So that's 2 times 2, which is 4, and the square root of 4 is 2. We're assuming the positive square root here because we're evaluating, we're not solving. So we have f of g of 2, and g of 2 we found is 2. So now we can replace g of 2 with 2. So let me see, let me try to, so g of 2 here is equal to 2. So now I am replacing 2 with 2. Okay, maybe I'll try a darker green so that shows up a little bit better. There we go. So now I've taken my output of G, and now that's the input to F. That's what we're doing here. You're plugging in a value for X into one function, and you get the output. And then you take the output, and now that's the input to the next function. And then you find that output. So f of 2, we're plugging in to f of x. So f of x here is x cubed minus 4x. So I'm replacing the x cubed with 2 cubed minus 4 times 2. So we're using these functions on the top. And so if you ever have a problem like this, they're going to give you your values for f and g. Specifically, they're giving us the numbers to plug in. So now I need to find f of 2. So I have 2 cubed, which is 8, and then 4 times 2, which is 8. And this is going to give me 0. So my answer to the original question here is 0. So we're asked to find f of g of 2. So 2 is your input to g. You got that answer. That's your input to f. And then you got that answer, and then you're done. So our answer here is 0 after we go through each of the parts. Are there any questions? Okay, so let's do the one on the right. So on the right, I've got g of f of 3. So our g and the f, they're reversed, so that we are plugging in to f to get an output, then we plug into g and then get an output. Okay, and a question to the previous one. So the answer to g of x becomes x in f of x. For the one on the left, that is correct, because we're taking g of x and putting it as the input into the f. On the one on the right, because the letters are reversed, it's the other way around. The answer to f will be then put into g. So the order of these things matter, because it tells you the order which one goes into which. So for the second one I have here, we've got an x, it's going into g, and then that output is going into f. And that's going to be our answer here. So we've got 3 for x, so we're going to find g of 3 and get some answer, and then that answer will go into f, whatever that number is. So the first thing we need to do is find f of 3. So I'm going to try to color code this a little better if I can. So I'm going to make, oops, and I just realized that I wrote this backwards. These are, I wrote the one on the left, what we're doing here. These are, we're going into f first for these, and then g. So very easy to get confused in the order here. So x is 3 because that's what's on the inside here. For f of x, it's now f of 3. So everywhere I see x in our function, I'm going to replace it with 3. So I've got f of x, but x is equal to 3. So I'm going to replace that with 3. And then we've got x cubed, and x is 3, so that's going to be 3 cubed minus 4 times x, and x is 3. And now I need to evaluate the right side. So 3 cubed is 27. 4 times 3 is 12. And then 27 minus 12 is going to be 15. So f of 3 is equaling 15. So that means I'm basically plugging 15 into g, the next part, because I've got g of f of 3, and we just found out that f of 3 is equal to 15. So now I'm doing g of 15. And g is the square root of 2 times x, or g of x. So everywhere I see x, I'm replacing it with 15. So that's going to be 2 times 15. And this will give us the square root of 30. And that actually does not, that is a radical that does not simplify. So that is going to be our final answer. The square root of 30. So if I do my best to kind of color code, we plugged in for x 3, and then we got an answer 15, and so that got plugged into the next function, and that got our second output here. Are there any questions? Okay. Looks a lot better. I'm hoping try to find the best way to show the work and explain the work because it can be very confusing. So here's another one. This time we have H and F. So the F function is the same function that we used in the previous example. H is a new one. And this time I'm using the circle notation so that you can get used to what the circle notation means and what that is. So we've got F, which is the x cubed minus 4x. And then we've got H, which is 2x plus 3. Now on the left, we have H compose F of -2. So when it's in that form, that means you're plugging -2 into x. And when we convert this to the other notation, it's H of F of 2. So you can see that it's in the same order that we have it in the circle notation. You just embed each one inside. So we're taking x, we're going to plug it into F, and then that output is going to go into H. So we've got -2 going in for x, and so that will give us F of -2, which will give us some number, and then that number will go plug into H. And that output will be our answer. So I need to first find F of -2. So everywhere I see x, I'm replacing it with -2. So I've got x cubed, so that's going to be -2 cubed minus 4 times -2. So we're using the same function for f. So -2 cubed is 8, and then -4 times -2 is a +8. So that gives us 16. So I've got my -2 going into F of -2, and that gave me 16. Whoops, I meant the highlighter. I was going to highlight that. There, 16. And then that's what's going to be plugged into H. So we're going to be replacing X with 16. The circle you go, okay, so the circle, you write it going left to right, but you plug it in right to left. So I don't normally think of it as go right to left. I normally write what it means in function notation. I will write this part and do it that way and work inside out. I don't really think of it as doing right to left, but you are essentially kind of doing right to left. So we found F of -2, which is 16. So now I'm going to find H of 16. So H is 2x plus 3. So it's going to be 2 times x, which is 16, plus 3. So 2 times 16 is 32, plus 3, and that gives us 35. So our answer to the problem, H compose F, -2 is 35. any questions? I'm trying to just do some color coding here to kind of help you maybe see what's getting plugged in where. Okay, so the problem on the right is H compose H of -4. So what this means is that we have -4. We're going to put this into H and get an answer, and then we're going to take that answer and put it in H again. So you're reusing the same function here. So first, I need to find H of -4. So that's going to be 2 times -4 plus 3. So 2 times -4 is -8 plus 3, and that gives us -5. Now, -5 is my output. That's what's going to go into H again, because we're composing H with H again. So we're using the same function over. So now we're finding H of -5. So that's going to be 2 times -5 plus 3, which is -10 plus 3, and that gives us -7. So H composed with H of -4, that final answer is -7. So you don't have to use two different functions. You can reuse the same function. You plug it in, get an output, take that new output, plug it in again. Are there questions? Okay, so here we've got an example. We've got our F, same function. We've got G, that's the same function that I used for G before, just so you don't get too confused, same one. And then H, the same H. So I'm just reusing the same F, G, and H. And this time we've got multiple circles. So we've got F composed with H, composed with G, and then you're plugging in 2. So F circle, oops, H circle G of 2 means you have F, you've plugged in H, and into H you plugged in G. So we plug 2 into G, we get some output, then we take that output and plug that into H, and then we take that output and we plug it into F. So you can do multiple compositions. You don't have to just do one function into another. You can do one into another, into another. You can do this as many times as you want. You just keep kind of adding circles. So G of 2 is where we start. So we have X equals 2, G of 2. And we actually found this already because we used it on the first example. That's 2 times 2. That would be the square root of 4. And that gives us 2. So if I'm color coding here, I started with the blue 2, getting plugged in. that gave me an output of 2. So that's going to be yellow 2, and that's going to be plugged in. So h of 2 is going to be 2 times x, so x is 2 here, so it's times 2 plus 3. So 2 times 2 is 4 plus 3. This gives us 7. So I plugged in the yellow 2, got an output of 7. So now our output is 7, and that's going to be plugged into the next function, f. So now we're going to find f of 7. Actually, I missed one of my highlights here. Let me just complete that. So f of 7, we have x cubed, so that's going to be 7 cubed minus 4 times 7. I don't know what 7 cubed is. I think it's like 764 or something. 343. I was very, very wrong. So 7 cubed is 343. 4 times 7 is 28. That one I do know. So we have 343 minus 28, which gives us 315. So our final answer is 315. So F circle, oops, H circle, G of 2 is 315. So if you're following the color here, that might potentially be helpful. So you can see how one goes into the other one, which goes into the other one. And it's like a chain of functions. Are there any questions? Do you have a recommendation on how to better write the little circle function? It comes out like my multiplication circles. That is an excellent question. So my multiplication, I make sure are closed. So, you know, for multiplication, I will make a closed dot, and I make sure that this is an open dot. So I would recommend that you make that difference, that your multiplication, you make sure it's closed, and then for this, you make sure it's open. I know if you've got a really thick pencil, that could be very difficult to do, but that's my best recommendation. Otherwise, for multiplication, you can do the star, and then that way you have a difference. So that's your other option, is to use the star for multiplication, so that way you don't get confused. Those are good questions, because we encounter so many symbols that you have to make sure you don't get confused. Okay, so here we've got two new functions. We've got k being -3 plus 1, and then m being 1 over x. And in this case, we're told to find k of m of x and m of k of x. We're not given a number to plug in for x, so we're just keeping it as x. What we're doing here is that your answer is going to be a new function. We're creating a new function, and we're going to have x in our functions. So color coding is another way that this is going to be sort of helpful so you can see what you're plugging in. And so I'm going to first rewrite this. This is going to be K of M of X. So we are plugging M into K. So I usually start with writing the outer function. K of X is negative 3x plus 1. And so we are replacing X with M of X. So I'm going to have K times M of X equals negative 3 times M of X plus 1. So I am actually replacing X with this new function. And so M of X is 1 over X. So from here, I keep the left the same because that's what we're looking for. And then on the right, I replace M of X with what it's equal to, which is 1 over X. So instead of plugging in a number, we're just working with the function. And then you simplify. So here I can do negative 3 times that fraction, and we get negative 3 over X plus 1. And that's our new function. What we've created here is a new function. So K of M of, so let me use the other notation they gave us. We have a new function. And when you plug M into K, your new function is negative 3 over X plus 1. Now, this is different from what we've been doing because we didn't plug in a number for X. The advantage of doing it this way is then if I asked you what is, let's say I said, what is K of M of 1, you can just use the new function that we created to get that answer. So negative 3 divided by 1 is negative 3, plus 1, you get negative 2. So the nice thing about doing your function composition and leaving it in an equation is that now you have an equation and you only need to plug in your value for X in one place instead of plugging it into K, getting an answer, plugging it into M, get an answer, plug into K, and get an answer. You can get your equation and then you only need to plug in your value for X once because you've already put the function inside the other function. And the order here does matter. So if we do the one on the right, it's M of K of X. You're putting K into M. So I start with my M of X, which is 1 over X. And I'm going to replace X with K of X. So instead of 1 over X, I'm going to have 1 over K of X. So you can see that I've replaced those. And then I replace what K of X is equal to, which is negative 3X plus 1. So this will be 1 over negative 3x plus 1. And we can't simplify that anymore, so that's our new function that we've just created here. And then if I wanted to find a specific value, all I have to do is plug in for x, and I've done that. So what I want you to notice here is that the order matters, because you can see that if the order that we plugged them in gave us two very different functions. And they would give us different values as well. If I plugged in 1, oops. So if I wanted to know what the value was at 1, I have -3 times 1 plus 1, I would get 1 over -2, while the other way gave me an answer of -2. So they're not always reciprocals like this. So you can't just, it doesn't always work out this way. It just happened to be with this number. But the key is, that the order matters here. Other questions? Okay, so here's one where we have a graph. Sometimes you'll see this and you have to use the graph because they're not giving you the equations. So we want to find f of g of 4 and g of f of 4. So we have f of g of 4. So we have x equals 4. That's getting put into g, so then we're finding g of 4. And then we find what f is for that value. So at x equals 4, g is the pink. So that's this point right here. So the y value is 2. So g of 4 is equal to 2, because that's the y value we're looking at. So now we're looking at, well, what is f of 2? So I go to x of 2, and f is the blue. So I'm like, okay, that gives me this point on the blue where the y value is 1. So f of g of 4 is equal to 1. It's a lot easier when you see it in graph form because the numbers are already there. You're just kind of reading them off of the graph. Then if we've got g of f of 4, so again, I have x equals 4. I'm plugging that into f and getting an output. And then I'm plugging that into g and getting an output. So when x is 4 on f, we're at -1. F is the blue one, so that's going to be -1. So now I'm looking at -1 and g, which is the pink. So when x is -1, g is at -2. So our answer to g of f of 4 is -2. Are there any questions? Okay. So now I want to talk about domain and range of these things. When you're plugging a function into another function, our input of one function gives us a range. So we've got the domain of one, and that output is the range. And that range is now the input to the next one. So the range becomes the domain of the next function. And then you have an output. So we're going through multiple and domain and ranges to finally figure out what the domain of the final composition is. It gets kind of complicated because we also have to think about, well, what numbers are we allowed to plug in F and what numbers can we plug into G, and we have to kind of look for where those overlap. So the general steps for doing this is to first find the domain of G, the first one it's going into, and then you take that and you use that to find the domain of F. And then you're looking for where these sort of intersect. So this will make hopefully more sense with an example here. So I've got two functions here, m and n. So m is the same one we saw before, 1 over x. And then we've got a new one, n, which is the square root of x plus 8. So first we're just going to find the function composition, m of n of x. So this is, we're plugging n into m. So I'm taking m, the outer function, and writing that m of x is 1 over x. And then m of n of x is 1 over n of x. And then n of x is the square root of x plus 8. So m of n of x is going to give us 1 over the square root of x plus 8. So we want the domain of the output. First, we need to think about the domain of the first function that we worked with, which was the 1 over x. So our domain here, it's all values for x except for what makes the denominator 0. So we can't make the denominator 0 because then we're dividing by 0. So it's basically all x except x equals 0. So x cannot equal 0 in that problem, or we're going to get an issue. Now we want to look at the domain of n, the other function, because that's getting, we're plugging something into that. So let me do this in a different color. Domain of n of x. So n of x is a square root of x plus 8. Anything that was function has to be graphable. So we can only have 0 or larger inside the square root. So x plus 8 has to be greater than or equal to 0. We can't have negatives in the square root or we can't graph it. Now we replaced inside, wait, no, this is, oh, I've got these backwards. That's fine. Domain of n of x. Okay. So we've got x not equal 0, domain of n of x. That's x plus 8. So if I solve this, you subtract 8 from both sides, I have x is greater than or equal to negative 8. Okay, so I've found the domain of m and the domain of m. So we've got the domain of m, domain of n, and n is getting plugged into m. So this n of x is getting plugged into the x, which is the other domain, because we're plugging n of x into m. So if n of x is 0 here, then I have n of x cannot equal 0. If n of x is getting plugged in for x. So our domain of m is x cannot equal 0. That comes from the fraction 1 over x. Now we're plugging n into m. So I replace the x with n of x. For the domain, I get n of x cannot equal 0. So now I replace and I find what n of x is, so that's x plus 8. And that cannot equal 0. And now we solve this for x. So you would square both sides to get rid of the square root. So this is one of the reasons why we learned about solving radical equations. We're left with x plus 8 equals or not equal to 0. The equal versus not equal doesn't matter. It's just a symbol. You can still use it. And then when we solve here, we get x cannot equal negative 8 here. So the domain is the overlap here. So I'm going to put a number line. And so we have our domain of n of x. And that the domain of n of x said that it needs to be greater than or equal to negative 8. So that would look like this. We can include negative 8. The domain, once we plugged n of x into m, says it's any value but negative 8. So it's like you have an open circle at negative 8. And it can be any other value. So that comes from this right here. The domain of our function composition is the overlap between these two. So the overlap is everything greater than negative 8. But it does not include negative 8 because negative 8 is not included in the other one. Open and closed circles are the same as brackets and parentheses. I did the open circle instead of parentheses because it just is easier to see in this case. The open circle means it's not included. The closed circle means it is included. So open circle is the same as parentheses. Closed circle is the same as bracket. So that was covered in week 1. So when we were doing the linear inequalities and sets and all that kind of stuff. So what this gives us is our domain for the composition is negative 8 to infinity. So you basically need to define the domain of like both functions you're plugging into, and then you take one of them, plug it into the other and find the domain, and then you find the overlap. There are questions. I'm going to do another one here. Same functions. We're just going to go the other way around. So we want n of m of x. So we're basically taking x into n of x and then into m of x. So m of x is the outside function in this case, and that is, nope, I wrote it backwards again. M, maybe I should not have used the letters N and M because I'm clearly getting them confused in my head. So first we're going into M and then into N. So our outside function is N, which is the square root of x plus 8. Let's see, we're going to try to color code this. So I'm going to replace x with m of x, because that's what's going inside of n. So n of m of x is going to be the square root of m of x plus 8. And m of x is equal to 1 over x. So this is going to be the square root of 1 over x plus 8. So I'm going to just leave that there, and that is our function. 1 over x plus 8 inside the square root. So we are plugging x into m, m into n, and now we want to find the domain of this output. So let's find the domain of m of x first. So we already found that previously because I'm using the same functions. X does not equal 0. So we know that x cannot equal 0. Then we've got the domain of n of x. So we found this before. N of x, it's x plus 8 cannot equal 0. This is the nice thing about doing the same function just in the other order. So x plus 8 cannot equal 0. But we're replacing x with m of x. So this becomes m of x plus 8 cannot equal 0. Because m is going into n. Then m is equal to 1 over x. So we get 1 over x plus 8, or is greater than or equal to 0. And so now we're solving this equation. So I subtract 8 from both sides, and you get 1 over x is greater than or equal to negative 8. So we don't like these type of problems where you have an inequality with x because you don't know if x is going to be positive or negative here, and that does potentially cause a problem. This makes more example than the last one. That's because I learned from trying to explain the last one, and I'm trying to make this one more neater. So yeah, this one should hopefully make more sense. So I'm actually going to graph this here to kind of solve this, because this technically is something that you haven't learned how to solve yet. So I made up this problem, and unfortunately I made up one with something you haven't learned how to solve yet. So we're going to just throw this into a graph to solve this for us. Okay, so I've got Desmos in order to solve something like this with what you know so far, we're going to put in the left side and the right side. So the left side is 1 over x, and the right side is -8. And I have to put in like y equals -8. So I'm going to zoom out. We've got two functions here. And this is saying where is 1 over x greater than or equal to -8. So it is above -8. It's greater than it. Basically, we've got an intersection point right here. That's a -1/8. And then it looks like this is probably at 0. Looks like there's, yeah, at 0 here, and then is when the next part is, because after that, between -1/8 and 0, it appears to be below. So we're looking for where is the 1 over x equation greater than the -8 equation. So where is it above? Greater than in terms of a 2D graph. So this, whoops. Okay, I'll go back to my pen. This comes out to, it is greater from -infinity to -1/8, and then from 0 to infinity. So I'm actually going to throw in a blank slide here so I can draw this graph. So we've got our number line here. An infinity, -infinity. And so our domain of m of x was that we can't equal 0. So I've got 0 on my graph. And I found I've got key points of -1/8 and 0 from the other one. So I've got -1/8. So our m of x cannot equal 0. So I'm going to just do the open circle again to kind of represent that. And then n of x, we found that we go from -infinity to -1/8, and then 0 to infinity. So -infinity to -1/8. And that one actually looked like it crossed. So that would be a solid or a bracket. And then at 0, it doesn't actually. So that's open or a parenthesis. And we're looking for the overlap here. So in this case, the overlap is going to be right here. We've got -1/8. It's on both graphs. And then we've shade to the left on both graphs. And then we're not including 0 on both graphs. And then we're shading to the right. And that will end up being our domain of the composition function, the new function we created. And when you've got two parts, you combine them with the union symbol. So I had also planned a word problem related to this, but obviously we do not have enough time for that. So I will leave that right here. So to recap the domain, we needed to find the domain for m of x, because that's the first function we're plugging x into. Then m of x gets plugged into n, so we had to get the domain of n and plug that in with m of x to get the other domain. And then you're looking for where those two overlap. So I drew the pictures and I'm looking, okay, where are these overlapping? And then that's the final answer. Are there any questions? Okay. So I am logging into Alex right now to verify, but I do not believe that the domain of composition functions is on the quiz because it is difficult. You know, you have to kind of go through these multiple things and it's confusing. I just want to double check before I confirm. Yes, so on the quiz, you will not have to worry about the domain or range part of the function composition. The only thing you will need to do on the quiz is like this kind of stuff, or the kind where you're plugging in numbers. So you won't have to worry about domain and range, and you won't have to worry about the graph one. So just want to make sure that that's clear so that you don't have to worry about, you know, all that complicated. Yeah, go back and stare at some of these bits. Yes. I think probably next term I'm going to redo this one and try to find a better way to explain it because it's confusing. This is still something that I'm still trying to figure out. What is the best way to explain what's going on? Because you've got a lot of stuff going on. But I think I'm making progress on a good way to explain it because it can be confusing. So yeah. So that's all I've got for you guys. Let me just look at my calendar because next week I'm going out of town for Thanksgiving and trying to pull up my calendar. So I will not be able to do our live next Sunday. I think I am going to try to do it during the day this Friday at like noon because I'm leaving town on Saturday. So I'm trying to get it done before I leave town because here at my my house I've got 2 monitors. When I'm going to be out of town, I'm just going to have my laptop, and it's going to be a lot harder to do a live. Plus, it's not going to be as quiet. So just a heads up, I'm going to be doing it at noon Central Time on Friday. I don't know. I haven't looked at what topic I'm going to do yet, but just a heads up that one's going to be rescheduled. Following weekend is going to be back on Sunday, but I have something that night, so it's going to be earlier in the day. But I will let you guys know. The whole travel kind of messes up with my schedule. So just a heads up about that. So, all right. Well, I'll let you guys go. Thank you for sticking with me on a difficult and confusing topic. I know we lost some people halfway through. They probably were like, this is over my head. But those of you who stuck with me, I appreciate it. And I'll see you guys at the next live. So take care.